Testing, testing. All right. I am going to show what absolutely is the most essential thing to know. And I'm going back to the best person possible to teach it, which is David Rutten, who created this whole monstrosity. And I had to ask myself, how come there's 4,000 subscribers, who knows how many viewers, and yet this fellow has 13 videos and 6 videos. What he does in his advanced data tree masterclass after you've had a year to play around with the fundamentals of Grasshopper is absolutely essential. And what I provided without permission, and I don't care, maybe I should. I've only spoken to him once, and it's been he corrected me a year ago when I was messing up my quotes, and I thank him for that. I certainly want to give him credit for this, absolutely. I wish I had this doc in front of me, and I wish I began with thinking beyond singular objects or lists, but lists of lists, and I wish I had understood or figured out the path mapper and relative items and the split tree earlier on. Now, he provides so much feedback in here when it comes to this. I put a link to his videos, and I put a link to his forums to know the formats for how to fill these things in. But as you go through that 6th series of the data tree masterclass, it would be nice to have the stuff alongside you. So what I've done, and I've made it interesting by populating with this little script here, a little tiny mesh skeleton that will jump onto all the points whenever you want them to. So that's just a visualization tools like a point tool on display, but it's a little tiny skeleton just to make this script a little more interesting for me and to have some fun with it. So I'm going to try and do this in 15 minutes. Good luck. In the first video, he really goes over and sets himself up with a grid. He sets himself up with multiple grids, simplifies the data, and shows you how that data can be played with if it was a single grid, but fails, or can be grafted, and it can be flattened. Sorry, I'm not talking flip matrix. It can actually be grafted and flattened, and what's happening when that's happening. And you can see the data structures change accordingly. And most people are familiar with grafting and doing that. And you have this point system that changes accordingly. So you can take a look at your point system from the flatten, and you can take your point system from the graft. So a great first video. However, he jumps immediately from that, and we'll take this visualization tool off, preview off. We may use it again. We'll take off the first video's disable, and we'll activate the second video, which is really a eye-opener for anybody in here. As he goes in, he basically makes a grid, and he makes that visible, and he takes that through a path mapper of going to null. You right-click on it, and it will set your path mapper to null. He shows how to flatten it, and you can see that that mimics in the path mapper what you were doing up here under your flattened tree. He goes in and he trims a list or cuts it down to A, so it becomes 2 branches. Actually, he does this, so actually you'll have a count. If I take the point system, and I am going to grab that down here. Actually, I just want to grab another one, and I think I had samples of it. Let me pull that one down here, and let's enable that one, because I definitely want to be able to use it. Oh my gosh. Enable. Let's pull the points out of there on the flatten, and you can see how the points are marked. I definitely want to upsize the size of those points, but you can somewhat see them. The size may be set. Oh, because it's defaulting. Let me also enable my number slider. So we have some big numbers. Flattened. We have it trimmed or separated to actually 2 number systems that it will get rid of the second indices when you're looking at it. So instead of having this, I'm going to copy that over if it takes a second and show you that basically it's getting rid of B on that path and just looking at the A, which distinguishes between, you're basically marking things as 0 and 1. He does a great example of that. That's good to have a handle on. So that brings you data in both instances. He then goes on and graphs the data, and he does he actually has it set up so you can actually just go to the graph mapping, which is nice, and you're left with this one being, actually, hang on a second. I've basically just done null data, but I introduced the indices into it. So I actually can have reference to the how many items there are in the list. That's not the graph yet. At this point, we're going to go in and take a look at this, and he's actually decided what could we turn all of those object begin lists into? And he counts through, and this is where you start to find out that it doesn't really matter what you name things. You can name this 123 if you want, and basically that would come up as all those digits have defaulted to 123. You basically got 15 branches, all with those items on the ends of the list. And it looks like you have 124, but you actually don't. You've just numbered the numbers that way. So I don't mean to confuse you with that. I'm going to go back in and turn that back to the number he recommends, which is basically dealing with 0, which overrides every point as it goes up on those items on the branches. He then jumps into this one, and he has 16 branches, which mimics a flip matrix. If you have items that come out as this type of data structure, it doesn't know if it wants to split the indices with this branch, the first branch or the second branch. So you have to go in specifically and swap the indices with the other branch item, be it A or B. So in that sense, you've continued through. We'll grab this point, pop it in here, and you'll see you have the status pushed it sideways from what you originally had in this form of counting 0 all the way up to the 6. You've been able to flip your matrix in that direction. You can try it on a 3-dimensional level if you feel like grafting up into a cube, which Daniel Christoph does so well. I think here was the example of going in and grabbing the tool and just hitting flatten matrix. So he shows that example, and these are the ones that he says he has in cahoots with. There's the graph, and there's your formula for graph. You simply bring the I inside of the path. You put a branch to every one of those indice items. Hopefully that makes sense. He trims, which takes off the B and just relieves the A, so you're left with a system that goes in and counts on each branch, flattens each actual item or geometry or plane that you're dealing with. He goes into a reverse tool, which mimics exactly what the reverse list does. So you can use this list, you can use this tool to reverse list, or you can actually use this graph mapper formula of item count -1 -I. This could be hard to get through. It's going to take a couple of videos. He does them in 6, but this is just to supplement that. Hopefully he doesn't mind me putting out my own text with my own video to allow you to have a working document as you go through those. It really is key that you're coming to understand the path mapper, the relative items, the split tree, and what I've done is I've made it so you can just click these items and zoom down to the script of where it's in use and have quick access to this. It is essential, in my opinion, of teaching this. And I'm preparing this for classes so people don't just get stuck in watching the videos. They actually have the script sitting right in front of them. So I don't mean to get too much ahead of myself. He goes in and he shows how to use a path index, which is very interesting. And not only grabbing the path index of points of what you're doing, he shows how you can add to it. And you can start your count differently, which I think is very interesting. Starting it at 7, you can also multiply it and have effect on those branches and the names of those branches as you go through. So another great example, but you're getting into here and you're adjusting your eyes to what the path mapper is capable of. He goes so far as to show with certain multiplication factors ending up with data like this, you're creating null branches in between, and then he shows the data structure. So it looks like you have more items than you think. And a clean tree will assist you with that. He doesn't cover that, but a clean tree will certainly give you an opportunity to remove those nulls later on if you want to number it in a different way. That's, I think, all I can get through in these 8 minutes. Well, I'll keep pushing it. I'll keep going. Let's take all those items and let's turn them to disable. And let's go into this one, which he makes with the third video, enabling. And this is just supplement to what he's done, exactly in what he's done. He grabs a single matrix, you can see, and he doesn't have to simplify it in that sense. And it has it's 6 branches. And it has, I guess if I simplify it, you'd see what would happen. It would go back down to the 1, and you'd be able to flip that matrix. But let's leave it open without the simplification, while keeping an eye on the time, 9 minutes. He does a null to show that there's 3 paths in that without the simplification. So there it is. And in doing so, he says, let's deal with relative items, and let's get into not wrapping the forms so they don't wrap around each other. He says with a plane, you wouldn't want to wrap, but with a circle or something like that, you definitely would want to wrap the data. And then he shows lines between it. And in the process, he maps, first of all, using the masks that can go into relative items, which is called the offset. He basically maps in and says, let's join this line to this line, this line to this line, this point to this point, this point to this point. And that's hard to see what's happening there, but it's basically bringing those together with a +1 in that C section. And then if you go up to here, you'll see that we've grabbed another point system with lines that will grab it from the 1 to the +1. So that's interesting to think how to create those lines. He then says, well, you can grab them in that direction. Let's grab them in both directions. And then he goes on and grabs them in all 4 directions and ends up with this. And I put it into a pipe so it's kind of interesting to look like, and you're starting to get geometries. So that's at the 10-minute mark. Let's try one more video of him to condense this hour-long seminar with supplements into something you hopefully will upload. You'll watch the videos and you'll have this supplemented. I'll provide it on GitHub within a week, a working document. And like I said, I provided this little funny kind of skeleton script that you can keep dragging down and having fun with to find out where your points are and pop the little pirates on where they need to go. This next one, as I look at it, I may have, which one we were dealing with? We were here, I think. Oops. Let me go back there and just leave that. Let's go into this one, which I just dealt with. Turn that one off, because that was dealing with relative items. Disable. And let's go farther down into here and enable probably just this section. Getting into his 4th video, he goes back to 2 grids, and he says, let's grab those 2 grids. And then in doing so, let's use the split tree, which I really have come to understand. And he very simply says, put your mask in and know that you could see all the items 0, 0. And you're looking at the data structure and you're saying, listen, I want everything with 0, 0, which will give you those 7 items. Because you've chosen anything that looks like 0, 0, it will select. He goes on farther and really does a great example of saying, okay, let's select all these ones and type them all in by hand. And that's a little awkward to think about, but let's type in all those items by hand, and you end up selecting all these items on each one. 0, 2, you selected all the paths as you go through, but that's tedious to type that all in. So he says, let's shorten that by bringing both the 0 path and the 1 paths into one way of writing it, so that makes it more concise. Theory of parsimony, Occam's razor, simplicity, whatever. And then he goes farther to say, use the brackets so it's clear and you can understand what's actually being selected. And then continue that path, and I think here I wrote the same thing again, so I don't need that one. I continue up here by saying, look, you want to select all those paths, and you don't know how long it is? Use the question mark to do that, which is a great way to get into this data and select the same thing. Then he says, listen, you can just go farther, and I've written this one again for some reason. You can actually control what's picked and selected from the the B section. So he goes into here, and once again, he's altered and grabbed every other one. He said, well, if you're going to grab every other one, in that you could do it as a range. You don't have to type it in all the way to the end, the same way you were typing in all of these as paths. Now you got indices, the path B that you're selecting through. You can do a range tool. And he provides the website that shows you all the different formats to these to be consistent. And this one, I've gone back and retyped the initial one so I can get rid of that. So then he says it doesn't work if you start using number sliders in your scripts. It can't understand that named, and it doesn't know where to reference it. So I put it in red as a danger zone. Then he says, listen, you can have a range set between things using 2. You can use greater than. And here's an example of that. And it's just basically here written out so you don't get stuck in the writing. 1 to 8, but not 5. Makes sense in both. And you're using multiple objects. I mean, you're definitely dealing in data trees. And now you're choosing that path, but you're saying not that. So you're ending up similarly typing 1, 3, 5, all of it. And then you can do less than or equal. You can do greater than or equal. And he keeps showing examples and examples and examples. And really, by the time he's exhausted it and shown all these wonderful patterns you can have, he says, listen, just go up here, go to this website here, and that will show you all the formats of what you can do. So you really want to sit down and get back into that if that's what you so choose to do. So that one said, I believe I was there, and I am nearly at the 15-minute mark. I'm going to hit disable, and I'm going to set up for the next one, this one, which is he goes in and uses the example of a circle, which he brings in, and I leave my circle. I do end up making it into a surface. I divide that surface into points. He shows you how points can hit and miss and create nulls and points. So we're going to start the next one with this format, and he shows some examples of and work, but not tucked within ranges, and you cannot work in negative notation. We'll continue with that, show some problems, and as he goes in the last 3 videos, he asks a lot of questions. But I've worked out all those, so I actually can come to really follow that tutorial. And once again, I'm giving total credit and thanks to David Rutten. Talked to you once. I hope this is appropriate what I'm doing. I'm looking that you've got 4,000 subscribers to these sets of 19 videos, and I'm impressed to say the least, and I only can hope I can step into this after a couple of years of playing with Grasshopper. Thanks very much for watching. We'll continue in the next series.